Hello. Bear with me a little bit before I prepare a few things. So the first order of business, of course, is going to be which wheel hubs we're going to use and which springs we're going to use for our suspension. We are going to use the wheels from the Land Rover, of course. That's a given. Yeah, but those are not adjustable anymore. You see, I have modified them because the problem was that when you twisted them, they would suddenly, if the thing was, if you were in a turn and the springs were compressed, and then you exited the turn, the springs would suddenly be shorter. So I took them apart and, of course, made them non-adjustable. So they are now stretched the whole time. Former adjustable springs. So what's it gonna be? Are we using LP power wheel hubs or regular Lego wheel hubs? Are we using these shocks or are we using these shocks? In any case, we are going to use Land Rover wheels. Yeah, so please decide. Choices. Meanwhile, while you're deciding, let me show you the charger. So I've, of course, replicated the A pillar on the other side, and I've been doing a little bit of bodywork Of course, I've done this part. I changed a few things in the door. Um, Here in the front, of course, we need to make some changes because the wheel rubs here on this part. So this is not gonna be okay. I'm thinking of doing something similar that in the rear by having here a little bit everything flare out a little bit, giving the car a more muscular look, not just straight everything. So we'll see. But the shoulder line, you see, looks well. And now just imagine uh, it flaring out here a little bit, like a muscular shoulder. I have a few ideas how we're going to do that, but that's not for this episode. Today we are going to do the wheel hubs, the McPherson front suspension by popular request. So yeah, you see, just as Leon said, if we use the LP power hubs, then that's it. You have to use the LP power shocks, LP power hubs if you want to build the suspension. But otherwise, if we do this, you can always use the LP power wheel hubs. But see, there's a choice. So yeah, I don't like these. But if I want you to be able to replicate what we're going to do today, and I guess that's the idea, because many people would like to have a McPherson suspension. Then yeah, then that's what we're going to do. Um, Let me just search for something. I hope I have another one. If not, yeah, I don't. Okay, then we're going to use these. It'll be fine. Okay, so what about springs? Do we use these or these? Because I don't think many people have these springs, and as I described before, I removed the part where they lock, so I can twist them as much as I like, and they will not lock. So yeah, because thing is, most people will not be able to make the suspension if I use these. So yeah, we're going to use the yellow ones. That's decided. That's decided. And another thing is that we are going to use we're going to have the whole setup be driven, of course. So it's not going to be as easy as just do McPherson suspension. That's bullshit. We need to challenge ourselves. So we're going to use the differential, of course, and these joints. And now another question. I don't make front wheel drive setups exactly because the steering angle is extremely limited. Now, having said that, these kinda provide a larger steering angle, but still very poor. Except if we would go and use a Dremel. Come on, camera, focus, please. Really? Can we focus? We can focus. Okay. A Dremel, and then we would remove this part. Remove this part so that the joint would actually be able to smoothly rotate. But right now here it can rotate. Here the transition is, let's say, it's a bit rough. It's very rough operation. I don't like it a bit. I don't know. At full lock it's problematic. Like this it's cool. But you know, if the suspension cannot go, the steering is not able to move enough, it's pointless. Yeah, the 8880 CV joint is exactly what I'm always aiming at. Yeah. Okay. So I don't know if we have room for bionicle joints. We'll see, because these wheels, as good as the insert is, the ones from the Bugatti, Porsche, Sian are just better because the rim has a larger diameter and we can do more with it. Yeah. So okay. So we are going to use the standard ball joints. Standard ball joints. We're going to use this, of course, because of course what we're going to do this naturally. We're not going to use the integrated CV joint. That one is complete crap. We're going to use it like this. Maybe even like this, because now that we have a bigger insert, I don't know where exactly the axle of the CV joint is going to be. So when you imagine the kingpin axle, we'll see where on this axle the CV joint has to be in order for it to be in the center of rotation. But in any case, we're using this guy, and of course everything can be much further inside of the wheel. I imagine it will be something like this here somewhere, because ideally we want the scrub radius, or the point where the steering axle contacts the road, to be somewhere here. Let's say here. And the wheel, of course, isn't going to do what it's doing now in the Land Rover, because in the Land Rover the wheel is doing this. So basically the whole weight of the car is on the wheel, and the wheel is this whole area here is scrubbing equally on the road, which does never happen in real life, because of the geometry. The wheel always tilts. That way, only a very small patch of the wheel is contacting the road. In when the car is stationary, of course. Uh, we're getting into the geometry while we're building the whole suspension. So we want exactly that. So the wheel needs to exactly tilt when we're steering, because when the car is then leaning, just as in the Charger, uh, the wheel is going to have the optimum contact patch. Otherwise, when the car is leaning to one side, if there's no geometry, there will be very little contact with the road. So yeah, now that we are now that everybody's happy with the decisions, let's start building. I don't know if this is going to be complicated or not. Usually it gets complicated when we get to the details. And I would like to make this suspension as wide as the Land Rovers. So the track of the Land Rover is going to be our measure. That's why I'm going to just bring it here and have it on my desk, just so I can, just so I can take measurements while I'm building. Okay. So, what do we need? First, we need ball joints. We need ball joints. 1, 2, 3, 4. These are going to be 2 of these are going to be for the lower wishbone, 2 for the steering links, and these guys are for the springs. Because of course what we're going to do is, this is our top spring mount. So this is going to be fixed to the axle, so the wheel hub, and this is going to be fixed on the body of the car. Because that way everything can rotate freely. Okay. Now let's get 2 of these. And 2 of these. And since we are going to have an anti-roll bar, of course, we need 2 of these, two more. So we're going to add ball joints while we move along. But okay. So we need to first see how much room we have. And this time our ball joint is going to be, unlike in the Charger, we can allow us to have the ball joint on the lower end. So let's see what we can do with this. Come on. No twisted axles. No, okay, of course. Just putting a few axles outside. Okay. So this time we can have the ball joint here, but not in this position, because here it's going to be the CV joint, but here maybe. Now let's see how much room exactly do we have. Yeah, that's not gonna happen. That's not gonna happen. Not, at least not in not like this. So our requirement is we need this guy here, and we need to have a ball joint here. we have this reversed. Let's see. Let's see how much room we have. If this is at all possible. I don't like it, but yeah. Nope, again. So, at this point, one thing is clear. We cannot have a normal wishbone suspension. But that's not a bad thing. What we are going to do instead is we are going to do basically a precursor of the Land Rover suspension. So if we want to upgrade our double wishbone suspension, our McPherson suspension to the elevated double wishbone suspension of the Land Rover in the next stream, why don't we do the lower part of the suspension like the Land Rover? So let's do the lower part instead of a wishbone, a multilink suspension, and then we have a McPherson, so a multilink McPherson suspension. Let's make it interesting, because obviously I think it's going to be easier. So let's see what the options here are. Okay, let's just try this out. Obviously, I'm just fooling around right now, just to see if this is viable. And of course, as usual, turned it around the false way. Yeah, we'll see. We'll see. Okay. Well, my first interest is if it clears these guys. So it should clear them, because now there's a slight pit in here, and it does. There's clearance, obviously. And of course, this guy here isn't going to be here, because we are going to use these guys, obviously. So there's going to be, this part goes to the front. There will be, come on, and we'll scavenge some pins here if we can. And this guy is going to the other side. So this one is going to the body. And again, it needs to be 6 studs, because our steering link is 6 studs. So our steering link dictates the width of this. So imagine we have now an attachment point here and one here. Now let's connect this to our hypothetical in the suspension bridge and see what angles we can have. What is the option here? So ideally we would have this guy here in between, because if we have it like this, yeah, no, it still has room. Yeah, okay, we can have it like this. So this guy can be anywhere here. And now we need to decide what the option here is. The main focus, of course, being, see, they're binding already. So we need something like this that allows us enough steering angle. The offset here isn't going to be much, of course. You have to imagine an imaginary line going through both of them, and when they meet, there's the intersection point. So it's not far off from here. It's a little bit further up inside here, the wheel hub. And of course, one other benefit that this provides is that shit's really nicely located. And of course, the steering angle here needs to be smaller than in this direction, so we need to scale it back a little bit. So we need more steering angle to go. So this is the front of the car. So we need more steering angle at the inner wheel than the outer wheel. So when this would be the outer wheel when cornering like this. So we can have this closer. Yeah, we can have this closer. There you go. See, this can be basically parallel. So like this, and this goes to the front. This is basically how the setups in the real car is. Okay, so basically like this. And now, of course, what happens in the Land Rover? The spring is mounted to these. So this the spring, instead of being mounted to the hub, the spring is mounted to these. But we're obviously not going to do that today. We're going to go for the McPherson, but doesn't matter. The main task of the lower wishbone is basically to locate all of this. So we achieve that. And mounting the differential and the anti-roll bar isn't going to be very difficult. So I think we should be fine with those angles. Should be. If not, we can always move this guy. Okay, so how are we going to do this? First, we are going to mount the strut. Make a temporary contraption to locate the strut, and then we are going to see how much width we need, and then we're going to do a suspension bridge, and we're going to use some frames to just mimic a car body, so that everything here is taken care of. We'll see. I'm, if we're going to build an Ackermann geometry, technically, we should then make the steering link in the back, because the Land Rover actually has the steering rack in front of the differential. But if you know Ackermann, the steering link needs to be somewhere here then. So in front of the in front of the lower pivot. Maybe there's room for it. Could be. We'll see. But the steering itself is the last thing that we're going to decide, because we need to mount the differential, and of course the rack needs to clear the differential. These are things that are not that important right now. What is important is how we are going to mount the spring to the knuckle. And for this, we need to mount this to see how much room we have in the first place. Okay, so we don't need this guy at this moment. Okay. So this isn't looking too bad. Of course, it's constantly moving because we need to fix it. Okay, so how much room do we have? Ideally, we would want to locate the attachment point of this as close to the wheel as possible. So basically here. And the angle, I don't know, we'll see how much angle we can get away with. If we achieve this angle, this would be nice. I'll be happy with that. I'll be happy with that. And we should have enough room here to actually make that happen. Should have. Okay, so we don't need this for the moment. All we care about is the top mount. Again, my problem with these wheel hubs is that either, I mean, I would be happier if Lego decided that they would have axle holes here instead of pinholes. The pinholes are stupid, because if I now have to use an axle is always gonna wobble, and the whole thing is gonna have massive play. So I'm forced to use something like this, but this then limits my other options. Obviously, we cannot have the spring mounted here directly, because it's going to interfere with our CV joint. So we must mount it one stud higher up. And let's do that. I'm just gonna put some parts here to the outside just to have them handy. You never know what we might need. Okay, so a fiver, and then we need to have it here. Okay, let's see. We need to constantly check, of course, with the wheels how much room we have inside the wheels. My guess is not much. Oh, come on. And I'm, of course, doing everything off camera because I'm stupid. Yes. Thank you, Mr. Spring. Thank you. Okay. So now the real challenge is how to keep it this way. What to put in here, what to put in here for it to stay. Okay, so here we suddenly don't have a lot of room anymore. I wish those springs were shorter as well, but they are what they are. How much room do we have? Half a stud. My god. How do we do that? I don't even know what to put there. Hmm. Of course, if this was a suspension that wouldn't have to be driven, the mounting point of the spring could be easily, I don't know, one stud lower at least. But, you know, that's what we want. So this is what we're going to do. So we don't have the luxury to have a whole stud here. And of course, whatever we put here, the spring would easily overpower it or just go there. So we need to be creative. We do have room here. We do have room here. We don't have room here. What could we possibly do? Well, let me check again. So, yeah, we have very little room. Very little room. So, ideally, this would be it. But in our case, I think we need to mount it here and go even further out to have a four stud assembly. See, this is what I don't like with McPherson's. I really like McPherson setups for all the other things, but if Lego made some sort of, I don't know, if we had at least one more stud here that we could do something with, but we don't. These springs are so limited in their application. I don't know, if there was an axle hole and a pinhole on this end, this would be perfect. But we can't have that. What we can do, and I'm just going to check with the Land Rover a little bit, because obviously the McPherson is going to will not fit anything else than the Land Rover. Obviously, it's way too high for a hot hatch. Yeah, it would fit a Land Rover. It would fit a Land Rover. Okay, listen to me. What we can try to do are two things. One thing is that we flip the spring around, do something crazy, like, for example, this, what I'm about to do. Wait for it. using something crazy like this. And let's use, I mean, sadly, the neck here is too wide. So sadly, we can use only this setup. Ah, come on. So we have our top strut mount that allows the movement that we want. And this guy is fixed. And we have ourselves a suspension. Of course, the garbage wheel hub is going to constantly move, but this is actually not. All the movement that you see here is from the slack in the wheel hub. All of this is just slack in the wheel hub. It's not the spring being mounted poorly or whatever. So we could have the suspension like this. Which older style CV joint? There's only three. There's the 8880 CV joint, which cannot be mounted here. There's the CV joint that's already present in here, which is total garbage, and it's way too far inside the wheel anyway. And then there's the new one. There's the new one, which we're going to use because obviously the CV joint needs to be somewhere here anyway. I don't know. Yeah, so the kingpin axle is actually, the kingpin axle would be approximately from here to here, something like that. So it's not much. It's not much. We could go bolder and move this guy one stud further to the inside. We could do this to increase the kingpin angle a little bit more, because this is, I don't know, could work, but maybe, I don't know, maybe it's just one stud difference between these two, or maybe let's say a stud and a half along such a distance. I don't know. But I guess, yeah, I mean, many new cars have a kingpin angle that's not that big. I guess we can always move this. So I would go with this for now. So where were we? Yeah, I'm going to use a longer. No, wait. I'm not going to use a longer disc. I'm going to use frames. Outright. Frames and dog bones. Yeah, angling the strut is going to be a bit difficult. Otherwise, we cannot make it work. Okay, so let's take the Land Rover first and see how wide no, that's not right. how wide this needs to be. No. Yeah, that's right. That's gonna be right. Okay. Where are we here? Okay. Uh-huh. Uh-huh. Okay. So somehow if we do it like this, yeah, this will be fine. Okay. Just so we know where the attachment point for our suspension here needs to be, how wide this is. So basically the width of our frame. Yep. The width of a frame. Okay. Okay. So not very wide, to be honest. Not very wide. Now we don't need the wheel anymore. And I would go ahead and replicate this for the other side. So we have two of each. I mean, two of each. We have two. I really wish there would be a better way to make McPherson suspensions. It's my favorite type for these kinds of builds because the frame itself, so the body rails can be as close to the wheels as possible, as we're going to demonstrate, as close to the wheels as possible, so that the engine bay can be as large as possible. And I like this because there's no need for an upper wishbone. And if you can omit the upper wishbone, that's a good thing. The McPherson suspension is not as bad as people think. It's not perfect. A double wishbone will always be better. But for most cases, even some like BMW M3s have all McPherson suspensions. So if it's good for them, it's good for me. Okay. Up until this point, they are still symmetrical because we don't have any steering links and crap like that. Oh yeah, just one. the ball joints are not going to be under much stress at all. And the 2-stud axle has to suck it up. There's not that much stress on it. It's not that much, to be honest. This is really not a high stress situation. Ah, come on. I have a feeling that we're going to exhaust my supply of ball joints. But that's okay. Okay. Every time when parts fall to the floor. Come on. Okay. Now we have to replicate or make our centerpiece. Now, centerpiece is of course having a differential inside. Differential, and of course the mounts for the ball joint. So let's see. Where does it need to be? Maybe we need to use this guy. Of course, I don't know where exactly the differential is going to be height-wise. Okay. So I just need to figure out how to mount this guy. Basically. So I will go. I'm going to mount to put this one in here, and I would put a ball joint inside, and then this is taken care of. But this guy, how would I mount? Yeah, well, of course. Answered the question myself. Okay, like this. Perfect. Another batch. need more ball joints. Because of course I do. No, I don't. I can take these. Of course. So. Okay. We're getting somewhere. So, the front suspension bridge, of course, is going to mount to the rest of the car with these two. So, there will be, we're going to build a frame chassis here that's going to hold these guys in, and it's going to combine these two. And then after that's done, after we know where the struts are going to be. Yeah, okay. See, one problem is that these guys, so our current mounting method doesn't allow enough suspension movement. What a shame. What a shame. I was hoping that it would, but it doesn't. Okay, so what could we do? What could we do here? I'm pretty sure the solution is simple. Okay, bear with me here. I don't know if this is gonna work, but we're gonna give it a try. So, that's for the other side. Yeah, well, that looks fine. That looks fine to me. Yep. Problem solved. There we go. Okay. Frame. Obviously, the frame is going to be much wider than this. Okay, wait a minute. What's this? What did I miss? Ah. Okay. So the snag here. These need to be. I mean, this needs to be one stud further into this direction. Okay. So which part is this? Let me Google. Bricklink part 32184. Ah, okay. I don't know. Okay, obviously we cannot use this setup like this. So since the differential is going to be here anyway and a bit higher up, so it's going to clear this guy, we can use a setup like this. Okay. Obviously, I have fucked up something with the geometry here. No, but that's exactly the width that we had. But obviously, no, it's not enough. They need to be one stud further apart, no matter what. So this guy needs to be one stud further to the front. Okay. So yeah, here we can use the exact solution that you proposed. That's okay here. Then these two need to be one stud further apart. Yeah, obviously. Oh my god, really? What is this? Okay, let's leave it like this. Doesn't matter. This is a cleaner setup anyway. Let's build the whole thing, and because we're going to have caster angle, that's going to change things anyway, and we'll see what we end up with. But I think, yeah, this is going to be a disaster. And if we have this guy on both, what then? Yeah, that's it. That's our setup. Okay, great. Now that we have this, we are going to build here. We're going to build attachments so that we can attach this to the frame rails. And for this, we're going to make ourselves kind of mock-up, because we don't know the height that this needs to be at. We don't know the height nor the width. So I'm going to use frames, of course, and we're going to mount something here. Let's say this guy, because it's wider on both ends, and build up on this. Okay, let's build some frames. So obviously we're just fooling around at this point, because we have no idea where anything should be at the moment. We're gonna have like 3 frames here, just so that they somehow sit on top of this. We don't really care much about anything else. I already see that we have, compared to the Lego Land Rover, we have like a massive engine bay. There's like so much room in here, even like this, and I think we can make it even wider. I don't know. At this point, I have absolutely no idea. I'm just trying to mount the strut towers, and then we're going to compare. Before these are mounted, we're not going to compare anything. Okay, so obviously that's the width of our engine bay regardless, because otherwise the springs don't fit. And I need to relocate this anyway. This was a bit optimistic from me. I can maybe do it like this. Nah, that doesn't work either. So let's say that unloaded and unloaded, this is what we have, and then when the springs compress, then obviously it gets well, it compresses. The car is going to be lower. So how do we mount these on the top? They don't need to swivel here, but this needs to swivel like that. Okay. So we need, well, ideally, but since these are the new turntables, we can basically use these guys. So I'm just eyeballing it here. I'm just eyeballing it. Yeah, let's, you know, we can do something like this. Yeah, let's do the 4. The 4 stud. This is going to be insanely crude, and I apologize in advance, but you know. So this is not possible, not with this, but we can use this guy. All I'm aiming here at the moment is I want to mount the top struts, the top part of the struts, nothing else. And then once this is mounted, we would see what kind of geometry we have, and we can decide from there on how to proceed. How to make better strut mounts and all of that, of course, because what I'm doing right now is garbage. It's just to locate this, nothing else. But you know, everybody that's been watching the stream so far with the charger knows that we here tend to rebuild things every so often. Yeah, I like this caster angle. Maybe too much camber. What do you think? Let's, I don't know. Let's mount the other one and we'll see. I probably should, yeah, probably should use a shorter one here as well. Just so that you don't get the feeling that we're building a skyscraper instead of a car. So okay, the frame is just as wide as it needs to be. Yeah, geometry looks nice. Yep, Ackermann should be doable. Yeah, I like it. It does have, yeah, it does have some camber. Does have some camber. But not really much. Are actually hardly noticeable. Most of the camber is because of the wibbly wobbly bearings, the hubs. So I don't know. Looks fine to me. Let's just check with the Land Rover what the if it's wide enough or not wide enough. I don't know. Oh, come on. Let's see. Yeah, it's even slightly narrower than Land Rover, ever so slightly. But if when it compresses, yeah, when it compresses is about thereabouts. So okay, that's fine with me. Okay, but first I want you to reflect on this. Do you see the giant engine bay that we have here? Do you see how much room there is? Compared to, let's say, this. I mean, there's no room here. Lego built everything completely. You cannot disassemble anything here without destroying everything. Here, look at this. Look at the room. All the structure is here. This is already pretty solid. And there's room for modules. So everything that is in here can be modular. The winch should be modular. So you when it's broken, like mine is, I cannot pull it out because I don't know, some of the rope got stuck or whatever. You can put it out and fix it. Engine, you don't like the engine, no matter. Undo 2 pins, take it out. I don't know. Steering, look at the steering, the massive steering here. So much steering for nothing. I mean, and it's so, I mean, it's so hard to turn even without wheels. There's so much friction. So now that we have this, we take the wheels off. And come on. There's three more things that we need to do. Drive, anti-roll bar, and steering. Hey Matvey, we are building a McPherson suspension. So you can also see that it has camber. Obviously, it has camber. Steering angle is good. There's room. It's springy. Yeah. And the mounting point here does not need much reinforcement. I guess we could pass the pin through and then have something going forward. Or not even that, because yeah, maybe some reinforcement on this side as well. The front, of course, is here. This is the rear, this is the front. Obviously, we're driving in this direction. You can see it by the caster. So front is this. So differential and all-wheel drive first, then we continue. I have a feeling that that this is going to bother us, but we'll see. Maybe not. Maybe not. First, what we need to determine. Let's get rid of this side. It's just gonna hamper us. So first, what we need to determine is where exactly the angle, where exactly the correct position for the CV joint is. Ah, really? Obviously, it's not here. Obviously, it's not here because it's moving. Yeah. It has to be here. Has to be here. Otherwise, it's in the way of everything. But I hate this. I hate this CV joint. Really hate it. It's in the way of everything. Good God. I don't know. It's not necessary. But I want to reinforce this guy here. Reinforcing the second pin is not necessary. I could do the same as here. See, make another two 3-stud lift arms on each side and then mount it centrally. Maybe. But I don't want to. It's not necessary. This works perfectly fine. I mean, yeah, okay. But that's because it's pushing inwards, of course. That's why I was holding it. This would happen regardless where we would attach it here, because the strut is pushing inwards. That's why you have a strut brace across them once everything is inside, so that you counteract them wanting to push inside. Yeah. Okay. So I don't like this. This is such garbage. mean, you could then use the old one, of course, this guy. But because this guy is way off center, look at what happens here. I don't know. This isn't good either. It's better, but it's still garbage. The angles, I mean, these joints just don't allow a lot of movement. See? That's all the joint allows. If I take the joint out of the equation, I can move the steering a lot more. But the joint limits this. This is all the joint allows before I have to move the axle. Such small steering angles. That's why I don't see. That's why I don't like to build front-wheel drive or all-wheel drive cars. No, the caster angle doesn't match any angle of Technic beams because the caster angle is like, I don't know, it's 5 degrees or something. It's not much. I mean, another option, of course, but this is just crazy, would be to use actual cardan joints. But there's a reason why they are not being used. First of all, it's way off center, so it's really not ideal. And with steering, the cardan joints get too much angle, and then you have jerky motion of the wheel. So out of all the options that we have here, this one is the worst, but it's still the best. I mean, it's a bad option, but it's the best that we have here. What ball bearings? What do you mean? There's no room. I cannot move these guys closer to the wheel. It's not possible. No matter what I do. Even if they're mounted here, they are not going to be any closer to the wheel. However, bear with me here. However, there's another option. There's always another option. What if? And this could solve many problems. What if we spread it out a little bit? I know this can cause problems because it's quite a little, I mean, it's quite spread out, but it's going to move the lower ball joint quite closer to the center of the wheel. This is going to change some geometry here, of course, naturally. So we need to adjust a few parameters. but you know, we'll see. We'll see. Okay. Okay. Can use that before. Okay, caster is about the same as before, but look at this. Look at what's happening here. So let's give the old chap another go. Hey, Doug. So this is not alright. What about these? This is better. I can still feel and see. You can see how much this moves in and out. It's way off center. I mean, this pivot that we have here is definitely better, I guess. But it's really it's the CV joint that really limits what we can do here. No, this is not for E30. This is us fooling around and trying to make McPherson suspension for a four-wheel or all-wheel drive car. Just fooling around. Technically, I don't know. It's generic. We're just taking the Rover as a measuring stick. So, okay. I mean, if we go with this, this is going to be a world of pain. Without all-wheel drive or front-wheel drive, this is going to be so much easier. I mean, this is now no problem. Let's put a wheel on and see what this means for the geometry. Okay, so oh yeah. Also look at how much room the wheel actually needs to turn. Hey, the Prover guy. Yeah, McPherson is simple. That's what I like it. That's why I like it. But of course, it's only simple at first glance. Once you get deeper, it gets complicated. So the issue with the drive here is going to be quite tricky. Quite tricky. I actually don't know what to do. I don't know. None of the options to drive our wheel is any good. None of it is really good. So we can either, well, we want to drive. I want to drive. I want this to be driven. But thanks to Lego, There's no good options. Damn it. I mean, we can like mock up something just to see just to see how bad it really is. So we need what is it, a 4? Yeah, like here. This can move, okay. And we can have it like what? This is 4 stats high. I know it's going to be atrocious, but I want to see it. I want to see it. Okay, so that's what? That's the long. You're saying that's the long. How is this too long? What you need? You want a 3.5 here? Can't be serious. 3.5 he wants. What if we don't have a 3.5? What if we would do this? Okay. Oh, okay. Needs to be one stud further to the back. Yes. Come on. Where do you want to be? Here. So it's like that. Okay. Now let's see. Let's see what we've got here. Okay, so this is roughly parallel, and this, see this? This is all that the CV joint allows. That's the CV joint that doesn't allow us to do any more. This is fine. Guess we could go one step higher here, but this wouldn't change this. Wouldn't change the fact that the CV joint just doesn't allow more. And keep in mind that this CV joint, you see this guy? Come on, focus. Focus, camera. Okay, you see this? I have already modified it. So this guy has more angle than a regular one. I cut away all of the limiting stuff. Yet still, it doesn't allow us a lot of angle. Well, any steering is better than none. That's the Lego philosophy. So when they do something garbage like this, they say, yeah, okay, just some small movement, it'll be fine. Just like in, I don't know, the cement mixer truck or the car transporter, the steering angles are, I mean, just just so small, just enough that you can say, yes, the car has steering. Is it any good? No. Well, fine, let's make it. Brickling part 92906. What is this? Oh, this guy. Yeah. Problem is that we wouldn't get any more steering angle out of it. I mean, I can try, of course. No problem. It's gonna be even worse. Because of the um, the the pivot point is very close here to the hub. So if we use this setup, it's going to be the same as with the older one, the newer one. See how much it moves inside. I mean, I don't know. Let's mount this to the test rig, to this guy, and let's see. Yeah, the movement is minimal. I mean, what the fuck? That's not even worth mentioning. That's not steering. That's a small suggestion of direction. I don't know. I'm so frustrated always with this. That's why I don't like to make cars that have any kind of driven front axle. There's just no quality components to do it. And my favorite one, the 880, I mean, this was perfection. To an extent, of course. This was garbage. This part was absolute garbage, but at the time, Lego, of course, didn't think ahead to make like a 3-slot attachment. So in this day and age, you could do a wheel hub that would have the back part of this. And there's, of course, the helicopter blade. this guy that can attach, of course, in here. And now imagine this being a little bit more sturdy, and imagine that this here would be this. I mean, and the hub itself then would be like 5 stud high, and it would have an axle point here, an axle point there. That would be something. There we go. Perfect. This, look at the steering angle. Look at the angle that allows. And it's still, you see, even at this angle, it still works smoothly. Now, whoever designed this was thinking. That's a proper CV joint. Everything else that Lego made is garbage. So, and what? Yeah, that's jumps out too easily. But you know, sadly, but it's fixable. It's fixable. Make it out of the hard plastic that these are made, and make these edges slightly bigger, and then it would click in hard enough that it couldn't get out. Yeah, you know, for this, I don't know, I would need to quality 3D print parts. All 3D printed parts that I've seen so far are garbage. They are not even close to what Lego is. Not even close. Basically, they require a lot of afterwork. So you have to sand them, and I don't know, and they're still not good. So what do we do here? I mean, I'm not happy with this. In terms of just the geometry, the version that we had before is better, of course, with the 2 stud connector. Yeah, I mean, let's do take 2 with the other connector. Ah, really. Okay. Okay, so let's give this one more chance. Let's give this one more chance and make this the proper height, I guess. No, we said it has to be here in the middle, of course. like this. So what do we need here? Is it 4? Is it, or is it 3? It's, yeah, it's neither. What about this? Yeah, I guess just mock it up, but it's neither one is good. It's not a 2, it's not a 3, it's something. Okay, so let's no, it's this angle is now too steep. Okay, so let's keep it at our previous setup. This height, just give it another spin. So the performance of this is very, very, very poor. There's like so much friction here between the this guy and the two steering arms, because even though we have space here, it's not enough. There's still friction, and on top of that, the steering angle is atrocious. And of course, when we are at the maximum steering angle, the amount of friction increases, of course. Yeah, oh my god. That's horrible. Yeah, but you see, 3D printing is always it's always a good option if you're just building a one-off for yourself. But whenever I'm building stuff like this, I'm always thinking about how people are going to reproduce what I'm doing, whatever I do, unless I don't know, it's really committed modification setup, like LP power engines, so switches, cylinders, glued parts, cut off parts, I don't know. But when we do models like this, I would like you to be able to reproduce this, but you can't, because it's not worth, it's garbage. This is unusable. This is unusable, and honestly, I have no idea what to do here. I would essentially just not make it all-wheel drive. Really, I would just ditch the all-wheel drive system and say we failed this challenge, and we can make anti-roll bar steering and call it a day. And don't get me wrong, I would love to make a car that is just front-wheel drive, for example, like a van or something like that. Really, I would love to make a model, a small scale model with these wheel hubs, front-wheel drive, and all of that, but I can't, because first of all, if I use the this garbage, the vehicle will have hardly any steering, and you will have, you will have to maneuver it across the entire desk several times in order to turn it around, or stuff like that. That's crap. I mean, this as a front suspension for something is good. We tried the carbon, Benny. We tried the carbon joints. The carbon joints are even worse. They are even worse. That's the problem. Because first of all, of course, they move the pivot from here to here, so one stud further inside, which we don't want, and then when they are in this position, the jerkiness of the wheel is just horrible. I mean, we can try it once more, just so you can see. I mean, I'm sorry that I'm ranting so much, but this is something that really drives me insane. Yeah, and no, I cannot even turn the wheel with the cardan joint there. Not even possible. So, not gonna happen. So frustrating. Yeah, so frustrating, and yeah, I don't know what to do. I mean, now that we, for example, decide, okay, we won't have a cardan joint here. We won't have a drive. Now we have more options with the spring setup. So we can use a different spring. We can mount it lower, and we can have an angle here. Hey Raul, well, we're trying to build a driven McPherson front suspension, but so far we have failed to make a proper CV joint because none of them. Sorry. None of them work, and it's frustrating the hell out of me. Uh, this one doesn't work because it's, for what it is, it's too big, and it's not. It doesn't allow a lot of angle without binding. Doesn't allow a lot of angle without binding. What else? This is a joke. This is a bad joke from Lego. I don't know. The angles are, I mean, what the fuck? This is not suitable for steering. The cardan joints, of course, are not suitable for steering either because they are too long. Come on. They're too long, and then at angles, cardan joints are not good at angles. And the joint that's actually good, so this guy here, this guy we cannot use because we cannot mount it anywhere. That's unusable. Lego made sure of that. The wheel hub is just made for helicopters and the 8880, but this CV joint, that's what we need. Oh, cool. Robotics is awesome. Yeah. Phew. I don't know what to do here. Really. We made the suspension, that's no problem. If we used smaller springs, let's say springs from let's say we use these, and let's say that we completely forget about the possibility of making a CV joint here, then we can make things a lot simpler still. So let's make that. So we have at least something to show for today, that we have made a small usable suspension for let's say rear wheel drive car, but you want to maximize the engine bay space. So we don't need this. We're going to have on the bottom we are going to have a charger style single mount point here. The 8880 hubs, where did I put them? Here. They are not usable. There's nothing here that we can use. Absolutely nothing. We don't need these. They are completely useless. This maybe, but I would also like to get rid of it. And ideally, here on top we would have, you know, like an axle, like here, exactly where the ball joint is in this height. We would have an axle hole here, an axle hole here, axle hole here, axle hole here. So 4 axle holes. That would be ideal. Then you could basically make anything out of this if we had those axle holes. Without those axle holes, forget it. And of course, a modified version of this with this guy glued on top of this. Ideally, this guy would be, you know, just like here, it would sit just like this. But you know, there's so much modifications necessary that basically you would need to print both parts, so you cannot really modify this. Yeah, where were we? Quit ranting and actually do something. I mean, I'm sick of my rants myself, to be honest. I would love to like Lego and love to compliment them. Yes, guys, you did such a great job on the new wheel hub that you made for us or whatever. But somehow they keep sabotaging the situation. They don't make the part that we need and want. But they make, of course, design parts for, I don't know, something, and they waste time and effort on making some wheel reduction hubs and whatever. These must have cost a fortune, and they're useless. They're useless. Okay. How do we want you? What if we want you like this? can mount him here. And we have excellent options to fix it here and then here. So there are possibilities. So what we could do, can use these guys here, mount this, let's say we use 4 stud axle just to be sure. Okay, so use this and this and this. Yeah, of course, must build from this side. Okay, so we use this and this. Is this enough angle? I don't know. We shall see. Okay. What does our wheel say? Our wheel says nope. It's too close. Too close? Okay. Nah, the bevel gears are not suitable for that. You can see the difference here. This is the reason, the shape of it is the reason why it's so smooth. The bevel gears, sadly, they are not suitable for CV joints at all. Okay, so this is a nope. This is a nope. Okay, we know that we cannot have anything here. This is already getting large. I hate this. Yeah, I guess one could. The yellow base. What do you mean? The problem is that if I use the setup that I wanted to use here, this is just, the wheel is just here. So I could move this one stud further out. I could. Yeah, I could, like this. I could do it. This would be easy to do. So we move it here. And then we can have something like, oh, come on, where are you? Something like this. And we put I don't know, either this or this inside. Let's try this. Nope. What about this? Yep. This is a go. Okay. So this would be doable. There we go. Now, depending on how low we want our car to be in this setup, we can see, we can, come on, we can have the strut support like this, which is maybe a bit low, or we can have it like we had before, like this, for example. And I mean this honestly. For example, if I was employed at Lego and I had to make a Porsche GT3, like the orange one. See, the Porsche has McPherson setup like this. See, and in a Porsche, this is game. That would be my GT3 suspension setup. So not what Lego did, but this. I would make this. So the suspension setup on the Porsche GT3 should be a proper McPherson setup, just like the real car has. And this is it. Of course, the wheels would be wider. That's okay. And the rims would be wider. I mean wider, the diameter would be bigger. So this would be completely legitimate. And since the wheels would be wider in this direction, of course, this would be well inside of the rim. And the geometry would be just beautiful. Imagine that. Imagine if this would be the suspension of the Lego Porsche GT3. So many possibilities. This would be excellent, and it's so simple. And then you just add a steering arm. You have perfect opportunity here to add, for example, if we turn it around, let's say this is the driver's side. Okay, things are falling apart again. Let's say this is the driver's side and this is the front of the car. Here you have the perfect opportunity to add, let's say, come on. Yeah, that's too much. Let's say this is maybe not too much. No, I don't have a Lego GT3. The moment I saw how it's done, I said just nope. There's no reason to get it. So imagine this would be our anti-roll bar. But you know, if everybody who has seen my E30 chassis knows that this can be done. So anti-roll bar would be possible. So I mean everything. That, and with the frames that we have, the front part of the chassis would be so simple. So I'm always so frustrated with this. I mean, yeah, in this case, the better option for the strut would be like this. Either here, we would have it either here, or even better, one step closer. That would be better. So it would be mounted here, you know, like this. And then, yeah, you know the jazz. Anyway, yeah, I mean, all of the supercars, at least the Porsche and the Chiron, would need to be re-engineered. The Lamborghini is, I guess, as a model, it's okay. I don't really have anything to say about the Lamborghini. I've seen the building instructions, the speed builds, all of that. It's just a generic Lego car. Okay, I'm fine with that. But with the Porsche and the Bugatti, there's so many missed opportunities. Those could be the best cars ever, but they're not. I mean, we have done nothing illegal here. No illegal building techniques. I mean, okay, we can consider, you could consider this an illegal building technique, but it's not really. Everybody can do this. It could be in the instructions without problems. Yeah, that's the problem with the Chiron. But instead of, see, Lego made the Lego made first this CV joint, and then they decided, maybe we would like this one because this one gets these two dislocate too easily. Now with this one, with the new one, it's really hard to get them apart. Yes, but this is just as useless as this. It's such a missed opportunity. If they went to trouble to make this, why not do this guy in the same manner than the 8880. That's what I would do. Do this like the 8880. That's the only way. Maybe a little bit smaller. There's an opportunity to make the 8880 joint a little bit smaller. The technology has improved. Uh, why not? Sure, but do it. I don't see I don't see the problem here. And then make one joint and produce it for the next 20 years. There's no need to reinvent them. The pins are around for 40 years. I don't know. If you make a new part, you don't have to make it re-engineer a part over and over again. Just make one good part. Yeah, we need a normal wheel hub that can accept such a joint. Lego should stop making wheel hubs that have built-in ball joints, or that are made specifically for the types of suspension that Lego wants to build. So double wishbone without geometry. Fuck that. I don't want that. That's such an easy cop out. We don't need that. We want proper stuff for the big wheels. Because there's so much stuff could be done if we had that. I mean, for rear-wheel drive vehicles, this is fine, because you know how much articulation do you need going just up and down for suspension. That's fine. But if you want to both have a suspension and drive, then this is not fine, and this especially not. So I don't know. It's really frustrating. No, I haven't contacted. As far as I know, Lego doesn't give a shit. Uh, I mean, there are people employed at Lego that are very passionate and know what they're doing, but the management at Lego has lost the plot. I mean, just look at catalogs. Look at the products Lego do. Not just for us, for adult fans of Lego. Look at what they do for kids. There's so little. No trains. Lego City is just one police station, one fire brigade, and two other sets. Like, I mean, in the 80s, there were like 20 or 30 sets available. Where's Castle? Where's Pirates? Uh, Train. I mentioned Train. Where's Space? They are just milking the licenses. Why the fuck? Who gives a shit about licenses? I want generic stuff that is fun to play with, not stuff that you buy, you put on the shelf and never touch again. That's not Lego for me. Lego is this. Lego is us tinkering with stuff, dismantling models, reinventing new building techniques. That's Lego. That's why I always loved Lego, and that's why I will always love it, despite all of the flaws. Yeah, sure. Okay, so basically these are the three components. You have the wheel, you have the hub, and the rotor. So basically this guy, see the two notches here? Two notches. Oh, camera, come on, focus. Okay, the notches. And then here on the wheel, you have grooves. So now this guy, see, connects like this. It's not a bad system as such. I don't hate it, and certainly the play here is, let's say, it's comparable to the current hubs. And then, of course, you put this guy in, and you have drive. And look at the steering angles. So beautiful. Really love it. It's still the best system. Yeah, Lego, I mean, all that shit with licenses and stuff, to a certain extent, I get it. Okay. But nowadays, basically, all of the Lego catalog are licenses. Everything is licenses. Technic, all of the other stuff, just licenses of stuff that's popular. And I don't know. I don't like that. I would like Lego to make generic stuff that is just Lego. I don't know. Like we said, Pirates were great. Castle, I miss Castle. Castle was great. Classic Lego Space. We have so much more science fiction stuff and space that actually happened since the 80s. Exploration stuff, and they could base a theme like they had back then with the blue classic space program. We need something like that. And trains, please. We need trains. We need a proper train program like we had in the 80s. The 80s and the early 90s with a 9-volt system, the golden age of trains, and then it disappeared. I always loved trains, but there's nothing. You can always make something with this, but you know, my biggest problem is this: I can do nothing with this. That's useless. These hubs are garbage. No geometry whatsoever. So, and this offset, of course, this is not usable. This is, for me at least. I mean, if you don't give a shit about geometry, go ahead. You can do whatever you like with this. But for me, I'm done with this. It's just a nice. Every time I see this beautiful CV joint, I'm just like, man, if this would only be available in the new hubs. Uh, deplorable guy. Deplorabology. Sorry, deplorabology. Please, if you make them, please, I want to see them. Uh, yeah, and you know, the powered up and whatever the new system is. This is, in theory, I get it. In theory, but I really don't want my Lego on the phone. I want a physical controller, because that one I just flip on and off we go. And with trains are not supposed to be remote controlled. Who wants to remote control the train? The train was perfect as it was with the 12-volt and the 9-volt system, because you had a single control, and then you had like a control panel where you had, I don't know, buttons for stopping trains or on certain tracks, changing the switches so the train would go on another track, and so on, from a single console. And that was great. You could play with multiple trains, didn't matter. But I don't know, this powered up system with batteries, Batteries are the worst. I hate batteries. Uh, the 12 volt and 9 volt systems were great because they didn't require batteries. You just plugged it in, done. Connect everything, and you are go. No batteries, and it's even better for the environment. And with the batteries, you constantly have to charge them, uh, change them in the controllers. That's such bullshit. Ah, sorry. I mean, the stream today is just one big rant. Yeah, but someone didn't do their housework with engineering, so they had to pull it. I mean, why would anyone use uh, eight stud gears in such? I mean, my God. I mean, let's just build it. I mean, I haven't built it yet. The mechanism. Let's just see how difficult it is to turn. Eight stud gears in I hate eight stud gears. My nemesis. Never like them. So the mechanism is like this. Oh, I don't have the new ones. I don't have the new ones. Oh, okay. Just the old gray ones. Wait a minute. My mistake. Yeah. 8-tooth gears are incredibly weak, and they have their use, but the use is very, very limited. I would say the best use of the 8-tooth gears is on the rack and pinion steering rack. Okay, I have barely enough gears. We're not gonna put a lot of stress on them, so it'll be fine. So what Lego did was this. Mm. So they actually dared to put any kind of power. Oh my god. What the fuck? Oh Jesus. See, when I'm not putting any force on this, it's fine. Then it goes really smooth. But just as soon as I put just a little bit of force on this gear, so I try to just hold it a little bit. These guys basically bind together. This goes nowhere. Oh my god. Look at that already. Deformation. The teeth actually catch up on each other. Oh my god. No wonder. This is absolutely no wonder that the Osprey mechanism destroyed itself in a short while. Oh my god. Oh my god. Yeah, I would never use this. I can understand why they did it, but I think the gearbox itself could be redesigned to not use these. Maybe to 16 tooth, but I guess the direction the axles turned was important. But still, that's horrible. Oh my god, these deform so much that at this point I'm just really not putting a lot of pressure here. And of course, this in the Osprey, this part is not suspended anywhere. It's just there. And of course, then you get you get this part of binding because of this and because of the deformation of the gears. So no wonder that this system failed. To the designer, of course, when there were no forces active, yeah, this is perfectly smooth. But as soon as some force is acting upon this system, oh my god, this is horrible. Yeah, I don't know. I'm so sad. So sad that Lego designers have become really, I don't know what to call them. And there's the Osprey is not their only set with issues, of course. Look at the Volvo loader, the new six-wheeled controlled car. The when the front and the rear are put together, the center part is so wobbly. Why? Why is that so wobbly? Why couldn't you use a big turntable? Then it would be perfect. Why not use a big turntable? The big turntable does not allow movement in this direction. It would be perfect for what they want. I mean, it's I'm really uh, I'm really out of my wits why this wasn't the case. Maybe Lego Bean Counter said, "No, this costs like 3 cents too much. Just design something else." I don't know. That I'm just you know uh, joking. I don't know what happened, what the reason was, but I would never design this way. Yeah, we're basically done. We're this rant is has gone for far too long. Um, yeah, so I don't know. Next episode, we're going to continue with the charger, to, and we're going to make some beautiful body lines. You can always write me a mail. I'm active on Telegram, Instagram, Viber. I don't know. I'm everywhere. On Facebook, of course. Fish. No. The problem is that the Land Rover is very poorly engineered. It looks beautiful. I like how it looks. Uh, the feel of the model is also fine. It's nice and sturdy, but everything mechanical on it is crap. Nic jasno. My Instagram is and same as on Twitter as well. Um, you can find me on Facebook on the LPA Power page, YouTube, of course. My email should be somewhere down there. So you can find me. Uh, Yeah, so I don't know. Thank you. Um, there's so many missed opportunities with Lego models. So many. Uh, the gearbox really needs complete redesign. Rip it out, rip it all out. Don't give a shit how Lego did it. Do it differently. I would also, while you're doing the gearbox, I would move. You see, one other problem with the Land Rover, a gaping problem. You see where the steering rack is. See, steering rack is here. Where it actually should be is here. The steering rack needs to be in the front, not here. In the front. And when it's in the front, it doesn't interfere with any of the drivetrain. Here it interferes with the drivetrain. And everything here must go. All of this is garbage. This is crap. This is not how a gearbox works. This does not belong here, these two axles. That's lazy engineering. The gearbox has... The main gearbox is on top of the rear axle. It has nothing to do here. There's... On top of the rear axle is only the trunk floor. Only the trunk floor belongs there. Yeah, so many gears for nothing. Nothing is happening here. Land Rover is such... It's looks beautiful. I want to like it, but I don't. And one day it's going to become a parts donor. It's going to become a parts donor for one of my models. Oh, come on. Those wheels are so difficult to... Oh, okay. It's so difficult to mount. Okay. I mean, look at it. It looks nice. It's really nice looking model, the Land Rover. It's nice looking. I mean, even the body it doesn't twist that much, but everything else. What the fuck? The gearbox should be the gearbox. See, the gear, everything gear related should have ended here. Nothing gear related should be beyond that, except the rear differential, of course. So that people who want to modify this into a four-door car could just chop it off here, add a section with doors here, and then re-add the rear to this. But as it is now, you have to basically re-engineer everything. I don't get it, and there's too much cramped into... I mean, I don't know. The layout is even wrong. I mean, we have the gear reduction and reverse before the actual gearbox, and then if you look at how the power is routed from where the engine is supposed to be, the power goes basically first from the engine into the rear gearbox, and then it goes from the rear gearbox to the center gearbox, and then from the center gearbox to the center differential. I mean, what the fuck? It's not supposed to be like that. It needs to be from the engine to the main gearbox, which should be located here, and then this sort of gears should be located behind the gearbox, so somewhere here behind the seats, and then this should then drive directly the center differential, which should be here, not here, just under the gearbox. There's so many unnecessary gears, and part of the blame is for where the steering is. The steering that is so fucking hard and difficult to steer, and it's hard to steer even now. We are off the ground. So much resistance, so many gears, so many unnecessary gears. I mean, such a shame. I mean, it's as a model, I like it. It looks great. It feels great, but everything mechanical in it is crap. Anyway, on top of this rather sad bombshell, it's the end of the stream tonight, and I see you tomorrow when we can. No, not tomorrow. Tomorrow is what? Tomorrow is Tuesday. On Wednesday, I see you on Wednesday when we continue with the charger. So take care. Work on your mocks and do something nice. And if you have something, please give me an email, and we can have a discussion. Anyway, good night.